This is a switch for turning on the alternator, and this is the controller for controlling the brushless motor. So I want to show you the brushless motor in operation, and it's wired into 40 volts. Now I'm going to turn on the alternator and look what happens. So that's the alternator excite, but the motor does not have enough RPM to spin that alternator fast enough for producing the voltage. Now I'm going to turn off the alternator. So the brushless motor, its coil will most likely get warm. So you're going to need a fan for keeping the brushless motor stator field cool, but still we have not achieved what we wanted to, and that is spinning the alternator fast enough for voltage. So it's back to the drawing board for developing a larger stator field with magnet for spinning that alternator. But at this point, we have gained the knowledge that the brushless motor is not efficient for spinning that alternator. So what we're going to do here now is we're going to remove this alternator and convert it internal to a permanent magnet generator where we will not be able to experience that load when the alternator is turned on. As a matter of fact, there is no way for turning on a PMG, a permanent magnet generator, which will replace this alternator on this side. And we're going to continue to use the current brushless motor and its controller with a less voltage. As you can see, it's 37.3. Well, that's because the battery has been discharged from 40 volts. And what's being used here is two 18 volts, and that's 2.2 amp per hour. This is from a cordless drill. So we are successful at gaining the speed. The only thing is replacing this automotive alternator with a permanent magnet generator where we will have enough speed, because right now this alternator is spinning at approximately 2500 RPM, which is sufficient speed for producing maximum amperage for charging the battery.